The electromagnetic spectrum will ranges from radio wave region to gamma ray region. So radio wave region, after that we will have microwave region, next infrared region, visible region, X-rays, ultraviolet region, X-rays and gamma rays. As we go from radio wave region to gamma ray region, the frequency of the radiation increases, whereas the wavelength associated with that region decreases. So when this radio wave region interacts with the molecule, gives rise to two resonance spectroscopies called ESR and NMR. ESR means electron spin resonance and NMR is nuclear magnetic resonance. So before going to discuss about this ESR and NMR, let us know what is the nature of spinning particles. So we know that in any atom at the center the positively charged nucleus is accumulated and the electrons are revolving around the nucleus. We know the electron will have the spin value either plus half or minus half, that is plus or minus half. Nucleus will also possess the spin. So this nuclear spin is the resultant spin of proton plus resultant spin of neutron. So let us consider the simplest atom, hydrogen. So in hydrogen we will have one electron and one proton and zero number of neutrons. So consider the protons, neutrons and the electrons. So the mass of the proton is 1.67 into 10 power minus 27 kg and the mass of the neutron is 1.67 into 10 power minus 27 kg and the mass of an electron is 9.1 into 10 power minus 31 kg. So these are the mass of proton, neutron and electron. Whereas the charge of proton is plus 1.6 into 10 power minus 19 coulombs. There is no charge for neutron and the electron charge is minus 1.6 into 10 power minus 19 coulombs. And the spin associated with the proton is plus or minus half. The spin of a neutron is 1/2. Electron spin is 1/2. Hence, the mass of an electron is 9.1 into 10 power minus 31 kg. The spin of the electron is plus or minus half. Whereas the nuclear spin or the nuclear mass is the resultant sum of mass of the proton plus neutron mass. Since in the hydrogen atom we will have only one proton, hence the mass of the nucleus is simply 1.67 into 10 power minus 27 kg. So the charge of the nucleus is the charge possessed by the proton. Since there is no charge for the neutron, so for hydrogen atom the mass is nuclear mass is 1.67 into 10 power minus 27 kg. The charge of the nucleus simply plus 1.6 into 10 power minus 19 coulombs. The spin of the nucleus is only we are having one proton in the nucleus. The nuclear spin is 1/2. Hence, the mass of nucleus is, what is the mass of the nucleus? Mass of proton plus mass of neutron. And the charge of the nucleus is charge of proton only. And the spin of the nucleus is spin of the proton plus spin of the neutron. The mass of the nucleus is mass of proton plus mass of neutron. Charge of the nucleus is the charge of proton only. The spin of the nucleus is spin of the proton plus spin of the neutron. So for this hydrogen atom, since the nucleus consists of only one proton, hence its mass is 1.6 into 10 power minus 27 kg, and its spin value, since it is possessing only one proton, its spin is 1/2. So the nuclear spin quantum number is represented with the letter I, hence I value is 1/2. Right. Next, consider deuterium. So deuterium means 1H2. Inside the nucleus, that is inside the nucleus, we will have one proton plus one neutron. Hence the mass of the proton is 1.67 into 10 power minus 27 plus 1.67 into 10 power minus 27 kgs for the deuterium. The charge is simply it is consisting of only one proton, that is 1.6 into 10 power minus 19 coulombs, whereas the spin of the nucleus is half for proton and half for neutron. So the resultant spin is either 1/2 minus 1/2 or 1/2 plus 1/2, the integral values. That is, the resultant nuclear spin, capital I, is either 0 or 1. For hydrogen, the nuclear spin is 1/2, having one proton inside the nucleus. For the deuterium, since the nucleus consists of one proton and one neutron, the resultant nuclear spin is either 0 or 1. For hydrogen, it is 1/2. For deuterium, it is 0 or 1. Next, consider boron. So boron's atomic number is 5 and its mass number is 10. So inside the nucleus we will have 5 protons and 5 neutrons. So maybe all these protons will orient in clockwise direction. All the 5 protons may orient in the same direction, or all these neutrons may orient in this same direction. That is, each orientation is represented with the value plus 1/2 plus 1/2 plus 1/2, 1/2, 1/2, 1/2 and 1/2, 1/2. Hence the resultant sum is 1 plus 2, 3, 4, 5. So hence the resultant nuclear spin is 5. Next, if one of the proton is oriented in this direction, another proton oriented in this direction, remaining 3 are in clockwise direction, all the protons are oriented in clockwise direction, then what is the resultant spin? So for this, spin is 1/2. For this state, the spin is minus 1/2. For this, 1/2, 1/2, 1/2, 1/2, 1/2, 1/2 and 1/2. So this becomes 0, 1, 2, 3, 4. Hence the resultant spin is 4. If one of the proton is oriented in upward direction, one of the proton is oriented in downward direction, one of the proton in upward direction and another proton is downward direction, if all the remaining protons are oriented in upward direction, then the resultant spin is, for these 2 the resultant spin is 0, for these 2 the resultant spin is 0. Hence this is 1/2, 1/2, 1/2, 1/2, 1/2 and 1/2. This is 1, 2 and 3. Similarly, we will get 5, 4, 3, 2. Next, 1. If all the protons are oriented in upward direction and all the neutrons are oriented in downward direction, that is with spin minus half, then the resultant spin is 0. Or if all the protons are oriented in downward direction, then the resultant spin is minus 5. So the maximum value of the resultant spin is 5 including 0, and the minimum value of the resultant spin is minus 5. So there are different orientations. Hence the nuclear spin for this boron 5b10 may be minus 5, minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3, 4, 5. Next, consider the carbon atom. So 6C12. So the nucleus consists of 6 protons and 6 neutrons. So all these 6 protons may orient in upward direction. If all the neutrons are oriented in upward direction, then the resultant spin is 1, 2, 3, 4, 5 and 6 plus 6 if all are oriented in upward direction. If we assume the same orientation in downward, then the resultant spin is minus 6. If all these nuclear spins, proton spins are in upward direction, all the neutron spins are oriented in downward direction, then the resultant spin is 0. So from minus 6 to plus 6 including 0, for this carbon atom we will have the resultant nuclear spins are minus 6, minus 5, minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3, 4, 5 and 6. For the isotope of this carbon atom, that is 6C13. So inside the nucleus, for 6 electrons we will have 6 protons. So then we will have 7 neutrons. So if all the protons are in upward direction, oriented in upward direction, if all the neutrons are oriented in upward direction, then the resultant spin is 1, 2, 3, 4, 5, 6. 6 plus half. 1 by 2 plus 1 by 2 plus 1 by 2, that is 7 into 1 by 2 plus 3. So that is we are getting the integral values. If some of the protons are oriented in upward direction, 6 neutrons are oriented in upward downward direction, and 1 neutron is oriented in upward direction, then the resultant spin is plus half. So we may get minus half, plus half, 3 by 2, 5 by 2, 7 by 2. Similarly we get minus 3 by 2, minus 5 by 2, minus 7 by 2. So thus we can write for isotope 13C, the resultant spin values are 7 by 2, 5 by 2, 3 by 2, 1 by 2, minus 1 by 2, minus 3 by 2, minus 5 by 2, minus 7 by 2. So if you observe all these atoms, consider the deuterium atom. So in the deuterium we will have 1 proton and 1 neutron, that is odd number of protons and for odd number of neutrons. What is the resultant spin? Resultant spin is integer. So if you consider the boron atom also, in the boron atom we will have 5 number of protons and 5 number of neutrons. These are also the odd values, hence the resultant spin value is integer, including 0. For even number of protons, that is for carbon atom, we will have 6 protons and 6 neutrons, that is even number of protons and even number of neutrons. The resultant spin value is also an integer. Whereas if you consider the isotope of a carbon atom consisting of 6 protons and 7 neutrons, we are getting the half integral values. So we can define the nature of nuclear spin as, if the nucleus consists of odd number of protons and odd number of neutrons, then the resultant spin is an integer including 0. All these cases for the deuterium, boron and carbon. So for the nucleus having even number of protons and odd number of neutrons, then the resultant nuclear spin may be half integral values. So this is regarding the nature of spinning particles inside the nucleus. These are all the nuclear spin values.